The methods that we've learned to solve are when we're solving a system. The first method that we did for the first 3 days of this unit was solving by graphing. Okay? So we've had solving by graphing. Then we've had 2 ways that are considered to be our algebraic. Okay? That means you're solving the equations. The first method was substitution. And this last method that we've been talking about, that we're going to do a little more today, is the elimination. So we are in your notes if you're following along, please. This is page 21. This is page 21. So, graphing, substitution, elimination. In all 3 cases, you can have one solution, right? You can have no solution. One solution in substitution is going to be when you have an x, y point. You can have no solution. That's when you had something like 4 equal 2, right? When you solve the equation in graphs, it's parallel. And you can have infinitely many in both cases. Infinitely many was you solved it and you got 2 equal 2. And that can work for both substitution and elimination. Okay? So we always have those 3 types of solutions. Like I said, next week we're going to have a quiz. The quiz will have you doing 2 graphing solving, 2 substitution, 2 elimination. So this one says we want to solve by elimination. So if we look at the problem, which variable do you think, by looking at the original problem, will be easiest to eliminate? A or M? Has the same number in front. M's have the same. They both have 1s, right? This one has 1 and 2.5. So what we are going to do is we are going to take that whole first equation up here, and we're going to multiply it by -1. That is going to leave us with, if we are writing that, as we write our new one, a -1a. It's going to leave us with -1m and -101. And now we are going to add. -1 plus 2.5 is going to leave us with 1.5a. 0m, which we're not going to write, equals 63. If you don't have a calculator, grab one. We're going to do our division to split. A equals 42. So we are now going to go back to one of our 2 originals. If we are looking at the original equations, Lucy, which one to you looks easier, the first or second? Ooh, the first one. So we're going to go to that first one, and we're going to put, instead of A, right, we're going to put 42 plus M equals 101. Was A equal to 42? Or just 42? Now when you solve it, I know, you're going back to the original, not to the one that's multiplied by -1. Because sometimes some of you will make a small, careless mistake when you do that multiply. So now we're subtracting 42 from both sides. Besides that, we want to solve for M, not -m. M equals, we do our subtraction and we get 59. Now, because you have not X and Y and you have other letters, and then we're going to get into our story problems, if there are 2 letters, they almost always go alphabetical. Just like X and Y are alphabetical, so a lot of times they'll write this answer AM. So if we are looking at our solution, we would put it as an ordered pair to be 42, 59. Sometimes they're going to leave it just like this. Other times, and so if it is not X and Y, I'm okay if you leave the answer like this. So just tell me A equals and M is equal. Okay? So, question, should you check? The answers are going to be in the back, but what you will notice, if we went to this, so if we were going to do that check really quick, you have your calculator, right? So if we're doing the check, 2.5 times 42 plus 59. Put it in your calculator right now. 2.5 times 42 plus 59 Is it 164?
Yes.
So we have it right. So as you're kind of doing your time. So this next one asks us if these says system A is equivalent to B because they both have this solution, 2, 2. If we were to graph both of these systems, they both have the same lines and points of intersection. Both systems have the same first equation. How do we know that the second equation is equivalent? What happened to that system A to get system B, the second equation? What did they do to that second equation here to get this, and to get this, and to get this? What's happening, Trina? Everything in that second equation was multiplied by 2. And what's nice about that is that now our y's are going to eliminate, which is what we are looking for. So it says sometimes we must rewrite a system as equivalent systems before the variable will eliminate. So which one would we want to use? We would want to use B. Now we're going to take a look at that. We want to use B is because when we add 2y minus 2y, it will eliminate our y's and give us 0, and you would solve for the x first. So today's homework, unlike yesterday when you were able to always add the 2 and 1 eliminates right away, today that is not going to be the case. So please take a look down at problem 3. We're not going to solve this one, but take a look at problem 3. As we are looking at problem 3, we want to solve by eliminating. And it says, I can add or, if we look at it, it says, can I add or subtract right away? It says, no, I need to rewrite either or both equations by multiplying and solving for the first variable. So if we look at these equations, do we want to eliminate the x's or the y's? And we are actually going to eliminate the y's. So put an arrow above your y's, which means I need to have a number that both 5 and 15 go into, and I want the smallest number possible that they will both go into, which is, wait. We multiply the second one by 3, but what number is that when we multiply that we want them both to be? 15, right? So we are going to actually multiply that second equation by 3. So please put multiply by 3 right behind that, right? And I don't care if you put it with a parenthesis, right? And you put multiply by 3. And we now want to do that. Does the first one change? Yeah. No. Please write that first equation exactly as it was written. And then that second one, we're going to multiply every single thing by 3. So the first one stays as 2x negative 2x plus 15y equals negative 32. The second equation stays multiplied. 7 times the 3 gives us 21x. And again, some of you like rewriting that as plus a negative 15. That's fine, or you can leave it as a minus. So when we add, we have 19x. Have your calculator. Negative 32 plus 51. We are adding those. We should have, what do we end up with? 19. So we get 19x plus 0 equals 19. We are going to divide both sides by 19, and our solution is 1. Now some of you at this point, this last step of dividing by 19, if you have 19x equals 19 and the next step you write down x equals 1, I'm probably going to be okay with that, right? Because you're starting so that you've been solving enough equations, okay, so as you look at it. If we are taking, look, we now need our second variable. You have to go back to the original equations. If we are taking a look at our original equations, first or second one, which one do you think, Hayden, looks better? Second one. So if we go, we're going to write down 7x minus 5y equals 17. We are replacing the x with 1. So 7 times 1 is just going to be 7. Minus 5y equals 17. If it helps you, if you like putting in the times 1, but 7 times 1 is 7. We're going to subtract 7. I get negative 5y is equal to 10. And y, when I divide both sides by negative 5, capacity is going to give us negative 2. So my ordered pair is 1, comma, negative 2. So I want to do a really quick check in that first equation. Lucy, can you tell me what I would write to do a really quick check? Negative 2 times. Yep. And 15 times a negative 2 we know is negative 30. And negative 2 times 1 is negative 2. So negative 30 plus negative 2. That checks and it gives us that solution. Okay. So sometimes we're going to solve, if we look at this one, it says be careful. Rewriting equations so that all like terms are in the same column. So if you notice, key thing I would recommend is that you usually try and keep it with an x, keep your y, keep your equal, and keep your number. Next year in algebra, you will learn this as a special form of your equations. It's called standard form. They don't really refer to it much in 8th grade math, but in Algebra 1 they talk about standard form of an equation. So that first equation, what do I have to do to get the x on this side? Because I already have 4x here, right? So we're going to rewrite that first one, and we're going to add 3x to both sides. Okay? So if I add 3x, I am now going to have 3x plus 2y. Right here is way over to this side because you're going to have to do a little work with this one. So 3x plus 2y. But I don't want the 1 on the same side as 2y, so I'm going to have to add 1. Equals 1. Second equation, is it in the form we wanted? 4x plus 3y equals negative 2. And this is the part where students will go, okay, someone says I want to eliminate the x, and someone else says I want to eliminate the y. It does not matter. You just have to choose. Okay, so Ella, you're going to help us choose which variable do you want to eliminate. Y. I'll go with y. So when we look at y, I need to have the number in front of y be the same number and the signs the opposite. So what can 2 and 3 both go into? 6, right? I'm going to multiply this whole first equation times. No. What am I taking 2 times to get 6? 3. So start multiplying, right? We are going to have our new equation, so write it out, please. 9x plus 6y equaling 3. Second equation. I need to have a negative 6 here. Stephen, as I'm looking at that, what am I going to multiply that whole second equation by so that instead of 3y, I have negative 6? Negative 2. And here's the deal. Sometimes I'll have some people multiply the first one by negative 3 and the second one by positive 2. Would it matter? As long as the signs in front of your y over here that we're eliminating are opposite. So, negative 8x. 2 times negative 3 is plus negative 6y or minus 6y negative 2 times negative 2. And this is the place where most people will make a mistake. They like to put down negative 2. They just forget. So either, like sometimes putting these arrows to show that you're always doing that multiplication, that helps some people remember. But usually what I'll do is when I look at your work, I'll look at the original problem, and I'll look at this, and I'll see that you just didn't multiply the last number. 5. So can we add them up now? So if we start adding, J words, 9x minus 8x gives us 1x, we like that, 0. 3 plus 4 gives us 7. Okay. As I am looking at that one, I now want to go back to our originals up here. Okay. So Haley, if I'm looking at those originals, which one do you want to go with? First or second? We're going to try and solve for y. First one. So, first equation, we're going to write 2y minus 1 equals negative 3. And you can substitute in instead of x, you can put the 7 right away. So 2y minus 1 equals negative 21. Alex, next step. Add 1 to both sides. 2y equals 20. Chase, y is going to be equal to? What did you say? 10. So my ordered pair.
Wouldn't that be negative?
Yeah, would it be negative 10?
Yeah.
It would be negative 10. It's negative 20, right? So, I just want to show you how easy it is. So we said it should be negative 10. But if we go back and we go to the second equation, right? So we said 7, 10, even though we know it's 7, negative 10. So this is how easy it is for some of you to make those mistakes. So we have 4 times 7, which we know is 28, plus 3 times 10, and we get, well, there's no way 28 plus 30 equals negative 2. But if this would have been a negative 10, then I can, oh, negative 10, negative 30. So then you don't have to erase all this work you've done. Because some of you, if you find one little mistake, you erase your whole paper, you erase all this work, and maybe the mistake was just that you didn't put negative 10 and you put 10. Don't go back and have to make yourself go through all that work. Try to find, when you do the checks, where is your last mistake. And here, maybe you didn't write negative 20, you just put 20, and that's how you got that one wrong. So, we're going to look at these next two. Okay? And I actually want you to look at the second one. Let's do the second one first. So, if we are taking a look at the second one, anyone want to volunteer for which variable you want to eliminate? Chase, what are you going with? You want y? Is anyone ever going to pick? Let's do x, just for a change. Let's pick x.
Why?
So what would we multiply by to get the x, the numbers in front of x being exactly the same? We want them to both be what? 4 and negative 4, right? So, what am I going to multiply this first one times?
You're going to want to multiply by negative 2.
Negative 2. Yep.
I'm going to eliminate both of them.
Well, let's try and see. So, right below, right behind here, right? Or actually, let's go down below. So let's rewrite it down below here. On your homework, my hint would be if you kind of write the problem down, then to do the work behind it. So the first one is going to be 4x. Then we're going to get negative 10y. Then we're going to equal negative 14. And we had the second equation already was negative 4x. Second equation was plus 10y equal 24. Second one doesn't change, right? So the first one is the one that we took times negative 2. The second one, if we were looking at it, was exactly the same when you wrote it. And do both variables change? Do we eliminate them both?
Yeah.
0 equals 10. No solution. false statement is no solution for our system. If I would have graphed these two lines, they would have been exactly parallel. They would have had two lines like this if I was graphing. But we would not want to graph, right? We get try our y-intercepts as we look at those. All right. Let's look at this one. The variable we are going to eliminate, Robert. Which one? If we're eliminating the y, I agree. In this one, you definitely want to eliminate the y, not the x, because we only have to multiply the first equation. What do I need to multiply it by, Maddie?
The first one?
Mm-hmm.
By 3.
By 3. Not negative 3, but just 3. So we are going to do that multiplication. I'm going to write this new one right below here so that then I can add these two. So I am now going to have 6x. I'm going to have plus 6y. I'm going to have equals 15. I'm going to begin adding, Sophia, as I'm adding them together. 9x. Yep, plus 0, so we're not going to write it. And 27. Nice numbers, right? No fractions or decimals so far. X equals 3. Which equation do we want to look at now? First or second? Which one? Doesn't matter. First or second? Second. So in the second, we're writing our 3 times 3 minus 6 times y equals 12. 3 times 3 is 9, which means what do we have to subtract from both sides? Minus 9. 12 minus 9 gives us 12 minus 9 gives us 3. 3 or 4. Equals negative 6y. Divide both sides by 3. Get 2. Negative 2. Divide both sides by our coefficient, negative 6. Yes, I was messing with it. Divide both sides by negative. But I will have people not liking fractions, so because there's a 3 and a 6, they'll divide both sides by 3 instead of by negative 6.
Maybe 1/2.
Yes. So y equals negative 1/2. So our ordered pair is 3. And I don't care if you put that negative 1/2 as a decimal or if you keep it as a
Big one. Juicy one too.
okay, as negative 1/2. Both ways are fine if you look at that. So infinitely many. Yeah, 4 equals 4. 7 equals 7. So yours